let's forget. Is it now? Don't forget to do the quiz. Quizzes are good. Go do the quiz. It's due tomorrow at 8 a.m. Yes.
I have a question from 11.6.
Yes.
Problem 27.
$27. Whoa. Okay. There it is. All right. Oh, I see. Yeah, what happens?
So it like you get zeros across the board.
Yep. Which means that one equation is a multiple of the other one. So this is a very interesting thing that I want to make a big deal of now, because I always forget to say this. So officially, that's called a dependent system of equations. It will have an infinite number of answers. And in this case, so is everybody with me? Let me show this problem. Come on, get up there. There we go. This problem here. So you can see that one is 3 times the other one, right? Well, it's negative 3 times the other one. So they're one is a multiple of the other one. There you go, Jeff. So I'm not given 2 independent pieces of information. Therefore, I cannot discover the answer. It's exactly as if I said, oh yeah, this guy, he's half as old as me. And I'm twice as old as him. Now tell me what our ages are. Well, that's impossible. Fool, you just told me the same thing twice. You old man. You guys kind of with me?
So
that's exactly what this is. Go ahead.
The answer key, it's weird. That's why
Okay, you ready?
Confused. Yeah.
The answer is always the points where they meet, right? If you graphed those lines, the answer would be where they meet. And if one is negative 3 times the other one, they're actually the same line. So the answer would be all the points on that line. Done. Is that what it says?
It has like X times something. I don't know. It's really weird. That's why I was confused.
All right. Well, don't pay attention to the answer key.
Okay. So just write infinite solutions, same line.
Yes, that's fine.
Okay, thank you.
Okay. So the same kind of thing can happen in 3 dimensions also. I think there's a word problem later that somebody was asking about earlier, where you get infinite solutions. Was it? Or was it? Yeah, it was infinite solution. Yeah. How's everybody else? You guys okay? Any other questions? If I think everybody here right now is here as a nice small group, so it's easier for me to remember. But just to make sure, if you didn't notice, the homework has been updated. The update to the update was updated. So I cut down on some of the homework, made some sections extra credit, just because we all need sort of a break here at the end. I did put the practice final exam up. So let me see. I don't know why I feel like I have to show you this. But if you go to modules, it's the very first thing. Bam! And I even put a little reminder about when the final's happening. A week from today. This is weird. I remember the semester ending like over a week after this normally, but I'm going to be done on the 9th, and then I got nothing to do. I can't go anywhere. The shit. Oh, well, I'm going to catch up on. I never watched that show Lost. Maybe I'll just watch the whole damn thing. I know. It's surprising. It surprised me too. And I'm like, oh, it sounds like a good show. I never watched the damn thing. All right. I wish I felt like watching Game of Thrones again, but season 8 exists. Anything else, guys? Any other questions to keep me focused? And don't forget, the quiz is up there. I've only got 5 people that have taken it so far, so take the quiz. Let's see, AOT. What is AOT? All other things. Anyone tinkers. What is AOT? Oh, dude, I'm all over that already. Are you kidding me? Erin. Sorry. Privately chatting with somebody. Attack on Titan was suggested to me, and Dudular, I know. Okay, I'm sorry. I'm sorry. It's really a little too easy to get me off topic. So no other questions from homework, guys? You guys are all caught up and going good. All right. Okay. All right. Let's jump back in to where we left off. There's going to be a lot of talking tonight from me. Let's see how that works. Here's what. Yeah, I'm not using my board much. Oh well. Just with you guys. So this is what we're looking at real quick last time. Ellipse. So let's actually try.
I can't really see the board.
Oh, I'm sorry. Hold on.
Okay.
Thank you, though. I always forget. Cheep, cheep. All right. Put you guys over there. Okay. Cheep. So, all right. I'm not going to go into what I normally go into. I'm not going to do the whole derivation of the ellipse. But the interesting thing about an ellipse is if you put like two nails down and you put some string around them and you put a pen here and you trace out a shape so that basically it's held in place by the strings, you'll trace out what looks like a sad, something, I don't know. You'll trace out an ellipse. So there's actually some math about the distances that you can do, and you actually end up with the equation that we've got here for basic, your most basic ellipse. So A is going to be length along the x-axis from 0. From the center, but the center here is 0, 0. B will be the length along the y-axis. It's crazy. Does A and B matter, the letters? No, just whatever numbers with the x talks about how far you go in the x direction. It's amazing. So if I had something like this, all right, so the center is obviously 0, 0. You guys with me? I'm not big on, what do you call it? Official names, but you have a major axis and a minor axis, semi-major, semi-minor. Who gives a shit? It's the distance along the y-axis, distance along the x-axis. So really, to graph this bad boy, oh, let me talk about one other thing. To find where the foci are, this is something that looks almost familiar. C squared, in this case, I really hate when they try to generalize this, but it's obvious, hopefully it's obvious that whatever the bigger one is goes first. Do you understand what I'm saying? So is it always b squared minus a squared? No, it's bigger dude minus smaller dude, right? This looks almost like Pythagorean theorem, right? Except it's got a minus in it. And again, if you did set up some of the math for this, you could actually prove why this C is this equation. We're not going to do all that. But just to find the foci for this, C squared would equal 25 minus 9. Another big mistake people make is these are already squared, right? You guys with me? The numbers that are there are b squared and a squared. So don't square them again and get things really freaky. So I picked a nice one. So that means that, and let me ask you this. Can somebody tell me, before we do anything else, is it going to look like this, option 1, or is it going to look like this, option 2? What do you think?
Option 2.
Totally, because it's going to go further in the y direction. So the foci are going to live on that major axis. So the major axis and the minor axis, because one's big and one's small. We got very technical there. Okay. So to graph this thing, I go out. How far am I going to go out in the x, both directions?
3.
3. Good. So it's, since that's a squared, a is the amount I go in the x direction. B is the amount that I go in the y direction. And of course, in the x and the, you can do it in the y direction. I'm going to go 5. Bam. That's a point. That's a point. That's a point. That's a point. That's a focus, and that's a focus. And then you connect them, and then you pray and you hope that it looks sort of like. Sure, that works. It's like the football that the Patriots used. Ah, yes. Bunch of cheetahs. That's all they are, is cheetahs. Okay. So the foci, so for example, the most famous example of ellipsis with the focus, ellipse with the focus, is our solar system. Our planets orbit around the sun. It's not crazy elliptical. It's almost circular, but we do go around the sun in an ellipse that looks like a circle, Jeff. It's very close to a circle, but just make it pronounced. Who gives a shit, Jeff? And the sun is actually at one focus, and the other focus is the Death Star. No, the other focus just, it doesn't matter. It's nothing there. And this has to deal with the conditions at the creation of our solar system and energy conservation going, that's why it's an ellipse, but it's just barely an ellipse. Is everybody semi with me? That's obviously not going to be on the test. Suddenly some astronomy stuff. We're not going to do that. Some cosmological equations are not going to be there. Okay. That's easy, right? You got to love that shit. You got to love that shit. That's so beautiful. So let's see, let's make an uglier problem and let's see if we can handle it. I'm going to erase all this stuff. Here we go. So let me make an uglier problem and then sort of let you guys do some of it on your own because I'm evil. Yeah, let's see. You could do it, Jeff. All right. Sure. Yeah, all right, that works. That's not bad. That's not ugly. That's easy. So notice something. For an ellipse, what has to be on this side to get it into its correct form?
1.
1. Okay, so this isn't too bad. See how far you can take this. Try to get the foci, and the center's easy. And then graph the bad boy. Indicate the foci on your graph. I'm going to grab something to drink.
I have a question.
Yes.
So if it's just x squared, would we still subtract a 1?
There's a 1 underneath it for sure.
So for like the c squared equals b minus a, would it be 9 minus 1?
Totally.
Okay.
Beautiful. So yeah, put a 1 under there. So now it looks complete. Now I can see what a squared is. I can see what b squared is. Fantastic. That's about it. I mean, this is nice compared to some of the stuff we've done this semester. And hyperbolas are not going to be that much more difficult. They're going to be a little bit weirder. So we get here. It's actually plus or minus, but that's why it goes both ways. You can simplify this a little bit. So which axis will the foci sit on?
Major.
In this case, that is the
y-axis.
Y-axis. I like it. All right. So this goes 1, 2, 3. 1, 2, 3. This one goes 1, 1. So you got your ellipse drawn. I gotta take a picture of that. Shit. It's like the best thing. 2 rad 2, I don't remember, is like 2.8. So my little focus, you put a little X, that might be better than put a little F. It's about right there. Now imagine this. A circle is just an ellipse where the foci have come and joined in the middle. Do you see how the further I push them out, the more elongated it is, the more squished it looks? So if I were to be able to just pull these together, it would make this become circular. It would be symmetric. Get out of there. In all directions. All right, now, is everybody with me on that? So I don't care if you put the focus as a point, who gives a shit. So this would be 0, 2 rad 2, and 0, negative 2 rad 2. Okay. Now, the only difference, what if this would have been, well, let's see, I'm going to erase all this. Here we go. Until somebody yells at me, I'm just going to erase this. Here we go. Assuming everybody's got this. All right, nobody's yelling at me. Okay. Real quick, what if it was, this? Right? A would still be 1, B would still be 3, but now where am I counting from? I'm gonna still go 1 in the X direction and 3 in the Y direction, but where am I starting at?
2, negative 1.
Yeah, now the center is 2, negative 1, so that's it. So you just set this bad boy up. Good job, Jeff. I forgot how much is which. Oh yeah, it's not too bad. All right, it's okay. So 2, negative 1 is now my center. So I normally put like a little open circle for my center. And then I count 1 in the X direction, bam, bam. And I count 3 in the Y direction, 1, 2. Well, you could do it, Jeff. 1, 2, 3. It's just your horrible scale. 1, 2, 3. There the bad boy is, same stupid thing. But now my foci, C is still gonna be this, you with me? But now my foci will just be 2, negative 1 plus 2 rad 2, and 2, negative 1 minus 2 rad 2. Are you guys with me? Because the foci just come right off the center. But why am I doing it to the Y? Because that's the major axis. That's the bigger axis. That's where all the stuff happens. Are you guys okay with that? That's not that difficult. Everything just gets shifted by this much. Another way to do it is to actually forget the shift, graph the ellipse we just did, and then move all the points over 2 down 1, right? That's another way to do this. But I like to do the center and then build off of that, so we don't have to draw the graph more than once. It's up to you. All right, I like it. Any questions on that? All right, so let me show you. Here we go. Here we go. I'm going to take all this away. Here we go. Nobody's yelling at me. Nobody's yelling at me. Okay. So let's do a couple of freaky things. What about this? What do you got, Jeff? Yeah, let's do, yeah. I like it. What the shit? What the shit do I do? That's a 1. It has to be a 1. That's great. That guy, you look great. You, what? That's not a part of the thing. That's not a part of the thing. What do? I force that shit down. That's I got you. How do I write this underneath so that it's still mathematically the same? You could do it. You
Is
could
it
totally.
4 to the negative 2 power?
No, well, sure. So, but what is that? It's just 1/16. Isn't something divided by 1/16 that thing times 16? Aren't they the same thing? Okay, I like it. So when you have a multiplier instead of a divider, like the form requires, you just reciprocate it and put it underneath because mathematically it's equivalent. We actually know this. We just don't see that very often. We don't have to do that. So what the shit? A is 1. I'll do that. Yay, Jeff. What's B?
1/4.
Yes, because B squared is 1/16. So what's C going to be? C squared will be, in this case, it'll be 1 minus 1/16, right? The big one minus the small one. 15/16. C equals plus or minus rad 15 over 4. Ooh, freakadelic. The process doesn't change. The numbers get a little bit more disgusting. Too bad. But the process doesn't give a shit. And you can just make, sorry, go ahead.
Do you need the plus or minus? Because doesn't the foci just mean it goes in both directions anyway?
True. That's why the first problem, I didn't even write it.
Okay, so it doesn't
The
matter.
plus or minus is sort of a reminder that it does add and subtract from the center.
Okay.
So whatever works better for you. It doesn't really care. I prefer like this because I know that's what the foci do. So I agree with you, but some of you guys might like the reminder. I don't know. It's up to you. Now you just have to make a good scale for yourself, right? What's the major axis this time?
X.
Yes, because that's bigger. So 1, 1, 1/4, 1/4. I have no idea why I did it like that. Why are you so big? Get out of there. Like TIE fighter wings. All right, so I can put a little thing there, a little thing there, a little thing there, a little thing there. Negative 1/4. So now I finally got a Stewie's head. And then this guy, whatever the hell that is, it's really close to 1. And you can see why. I mean, this is pretty squished. So my foci are going to be really close to 1. Whatever the hell that actually is, I have no idea. But it's really close to 1. Maybe I'll never know. Well, I can live with that. I don't need to know what that is. All right, how do you guys feel about ellipses? So good so far, right? And I say it that way because here comes your ultimate problem. Okay, I'm gonna erase all this. Oh my God, am I gonna be able to make a good problem out of nowhere? I don't know. Let's find out, Jeff. Here we go. Everybody buckle up. Let's see. Oh. Sure, I like it. Sure, I like it. So far, so good. Yeah, maybe I can just do, well, shit. Let's see. You could do it, Jeff. All right, I like it. Now let's think about this. All right, I like it. Yeah, so that could be, all right. that's going to be all right, so let's hope that works. Okay, let's find out. What do I do here? How do I know this is an ellipse? And not a circle. If I took one number away, this would be a circle. If I took the 4, if I took the 4 away, it would be a circle because now X and Y both have the same coefficient. Or if I added a 4 here, it would be a circle. Ellipses have different coefficients on their X and Y squared parts. All right, so that's why I know it's an ellipse before I do anything. Right. Also the fact that these are both squared, obviously. If that wasn't squared, this would be a parabola. Now what do I do? So what? I know it's an ellipse. How the hell do I get this in the right form? What do I do?
Do you factor out a 4x and then?
No. You factor out a 4 though, and you leave some space. Oh, you can do it, Jeff. There you go, buddy. So I'm giving a major hint. So what do I do? What do I do? Break out a new marker. Anybody have an idea? I said it last time. I said this was going to happen. You did me well. All right. I'm going to have to complete the square. Half of -2 squared is 1. So what did I just add? Or are you going to be a shitty one? No, you're good. What did I just do? Is everybody with me on that being 1? You guys remember this? Half of -2 is -1 squared is 1. So what did I actually just add?
A 4.
A 4. So I better do it to that side. Half of -6 squared is 9. So better add a 9. And let's see what Jeff has wrought here. Now it looks closer to where it's supposed to be, right? Yay, Jeff. Are you guys with me? You're going to have to do some completing the square stuff. Less than before because I cut down on the homework, but I made sure to include problems like this. And then, of course, what do? The only thing that's wrong in this right now is
Do you divide by 36?
yeah, because there's supposed to be a 1 over there. So the power of knowing the form of what you're working with, right? So that is the form of an ellipse, sure, but this is the most practical way to write an ellipse because now I can tell, you know, what A and B are. I can tell what the center is. So the center would be 1, 3. The foci c squared would equal 36 minus 9, 27. So c is 3 rad 3, plus or minus if you want. Right, square root of 27, is that cool? Maybe, maybe. Well, let me be careful. So foci, c equals this. So the foci, you'd have to build off of this guy. Is everybody with me? What's the major axis going to be? It's going to sit in the what direction?
Why?
Good. The major axis will be in the y kind of direction because that's the bigger one. So the foci will sit. So the foci points will be 1, 3 plus 3 rad 3 and 1, 3 minus 3 rad 3. So that's why it's not a bad idea to put the plus or minus there to remind you that you add it to the right place, depending on what your major axis is, and subtract it. All right, and then you graph it. So A is 3, B is 6. So my center is 1, 3. Jeff, what are you doing? I don't know. 1, 3 is my center. So I go 3 in the X direction. 1, 2, 3. 3 in the Y direction. I've lost interest in this problem. 1, 2, 3. Who cares? You guys, I can think at the point. 6 down there somewhere, 6 up, and there's the thing. And then your foci, you just plug that in the calculator, see what it is, and plot them in the right place. Plot, plot. All right. Beautiful ellipse. I almost made it through this point. All right. Okay. So that's ellipses. Not much to do with them. Ellipses. Let's talk about hyperbolas. And the only real difference between the equations for ellipses and hyperbolas is there's a minus. One of the two is negative. So if I have something that looks like this, let this be so cool. This will look like this. I'm just going to do this and see if you guys can tell why. And if I have something that looks like this, it will look like this. So now watch this. Why does this make sense? What kind of intercept does this not have?
Doesn't have a y-intercept?
Yeah, and how do you get a y-intercept? You make x 0. Can you solve that? No. Not using real numbers anyway. Do you want to bring complex numbers into this? No. Some of you guys maybe. I think most of us are like, no, it's okay, John. So we're only dealing with real numbers. There's no way in hell that's going to have. So that totally makes sense. If the x piece is positive, it sits on the x-axis. It's going to have x-intercepts. And if the y piece is positive, it sits on the y-axis. It's going to have y-intercepts. Now, unfortunately, again, there is a lot to these, such as some comets have hyperbolic orbits. What else can you talk about, Jeff? I don't even know. Oh, it's gone. All of my brain is gone. And then the math behind why this looks the way it does. Do you guys remember, we did talk about hyperbolic. Did we talk about Coche and Cinch? Really? Damn. Maybe that wasn't part of it. I feel like I talked about that not that long ago. I don't know where that would have been. Oh, well, in your dreams, Jeff. Yeah, that's true. Here's the interesting thing about this. If that was a plus, it would be this ellipse. It's kind of neat. There's like what I call the associated ellipse. So I don't know if that makes any sense to you guys, but it's kind of nifty. If that was a plus, it would just be in here. Now watch how you can do this. This is kind of awesome. So obviously it doesn't have the same idea as semi-minor and semi-major and all that kind of shit. There just is one axis where everything's happening and the other axis that we're all avoiding. So for example, here's what, this is so cool. If I have this, yeah, let's just do something not too evil. There we go. Look, that's almost too nice. Now think about this. The smallest x can be, I really want you to understand this. The smallest x could be would be if y is 0. Do you guys see that? If I make y 1 or 2 or 3, then x has to be that much bigger to still equal 1. Yes, maybe? I can only see one face, Amber, so I'm always going to you for like a reaction. I'm sorry. So if you don't have a reaction, you can look away like you got a phone call or something. All So 3 and -3 will be these points. That's the closest approach. So if the Earth is here, that is the closest this comet will get. Hopefully 3 million miles or something like that instead of 3 miles. That would be bad. Right, so that is an actual point on the graph. This is not totally useless though. Here's how we use this. All right, and this is where that shadow ellipse idea comes in. I can draw, and some of you guys say, well, no, you can't, Jeff. Well, let me finish my sentence. I can draw a little rectangle. I'm going to go 2 out in the y direction. And I'm going to go 3 out like I already did in the x direction. Jeff, really? Really? I don't know. It probably looks really crooked from there. Oh, yeah, it totally does. Oh, it looks beautiful there. It looks really freaky there. Okay. Oh, well. Now I'm gonna prove this in a minute. But here are asymptotes that go right through the corners of this box. And then my hyperbola, so my ellipse would live inside this box. Do you guys see that? It would touch it at all the midpoints. That's really cool. And the hyperbola is like the kind of like the opposite of the ellipse in a way. So one thing I forgot to do, and I really hate that I forgot to do this, is this, an ellipse is contained. And you can tell just graphically, let's make it an ellipse, Jeff. There we go, buddy, good job. So you can tell graphically this thing is contained. It's not allowed to go to infinity, it's contained. And that's because if I want to add 2 things to make 2 positive things to make 1, when one gets bigger, the other one must get smaller, and neither one can get too big. If one is 0, that's the other one is as big as it can be. Okay, if I subtract 2 positive numbers to make 1, one can get as big as it needs to, as big as it wants to be, as long as the other one is 1 bigger, you know? So that's why this is uncontained. So I love this little box. It's sort of like the ellipse box where the ellipse lives, and if that's minus, oh shit, that's the uncontained part. Now, can somebody tell me what the shit, what the hell this line's equation is? I love that question. It's very easy. What is this line's equation? It goes through the origin.
Y equals 2/3 x.
Yeah, y equals 2/3 x. Isn't that, let me see, isn't that, yeah, this is perfect. Isn't that b over ax? And of course, what's this line? That's 2/3. That's going to be
-2/3.
There you go. So it's be plus or minus. I like it. So somehow the asymptotes of this thing are this. What do asymptotes mean? How do I figure out the asymptotes for a given, and not vertical, there are no vertical asymptotes. How do I figure out these slant asymptotes? How do I do that? I let what get what? You can do it. You can do it. I know you can do this. To figure out horizontal asymptotes, I let what get vary what? No, we've forgotten. Oh, shit. I let x get really, really big. No? Damn it. I let x go to infinity. So let me real quick. The way it's written here is no good. If I let x go to infinity, that doesn't tell me anything. So let me see. Let me just do this real quick. If I if I solve for y, right, if I basically just switch those, stay with me for a second. I'm going to do this kind of quickly, but I'm going to multiply by b squared. You can already see neat things happening. Become a b squared. Right, so look, okay, yeah. And then I can do this. I'm going to take a b squared over a squared out. Now let's see, is everybody sort of with me so far? So I solve for y. Now I'm going to do a little bit of weird shit. I'm going to take a b squared over a squared. So the b squared comes out, and the over a squared means there's an a squared in there now. And then I can do one more thing before I take a square root. I can actually take out an x squared, which makes this 1 minus a squared over x squared. Then I can take a square root. Let me give myself some more room. Get out of here. So square root of b squared over a squared is b over a. Square root of x squared is x. Square root of this thing. Now, what happens if x goes to infinity? What happens to this? You could do it. Let the bottom get really, really big. The whole thing goes to what?
Approaches 0?
Yeah, remember that? Remember doing that shit? So isn't this square root of 1? Isn't this become just this? Which is exactly what we saw that it was? All right, that's all I'm going to talk about. That's a little proof. Do you even have to necessarily remember this formula? No, because you draw the box, go through the corner, and then you can just see what the hell the equation is, right? Okay, I like it. What I hate about this is saying it's this depends on what you call B and what you call A, when it actually is always just the thing under Y over the thing under X. I mean, I don't know if that makes any sense, but if you just draw the damn thing and do it, you can see what it is. That's almost too nice to believe. So how would this have been different? How would this graph have looked differently if this was negative and this was positive? Would I have to redo this? I could erase this, but now what's the difference? Which axis will it sit on now?
The y.
The y. So it's just going to be here. Same freaking rectangle. Do you understand what I'm saying? I sound a little insane, but you know, that's par for the course. Well, I could do like a Khan Academy thing. You'll never see me. That would be interesting. All right. Okay. And of course, I could have this not have a center at 0, 0, but you just move it and then build your rectangle around wherever the new center is. It's not horrible. It's actually pretty nice. I always thought these were kind of relaxing problems. Could be just me. Okay, enough of this. Believe it or not, the one that's kind of the worst are parabolas, which are kind of weird because you've done parabolas forever. The problem is you've never done the full technical definition of what parabolas are. And the full technical definition is kind of gross. So here, it's kind of interesting though. So there's, if I'm given a line, and I'll call it the Directrix. Oh shit, that's the name of the line. Don't give me any shit. It's called the Directrix. Right? It sounds, I don't know, it sounds a little iffy. I want to back up out of that club. And you have another point called the focus. Okay, that's good. I can handle that. So the really freaky ass definition of a parabola that you never hear until you get to this point is it's the collection of all the points that are equidistant from this line and this point. What the shit? So if this is P and this is P, and I use that letter for a reason, obviously this would be a point on the line because that point is equidistant from that point and that line. So some other point on the line would have to be, let me see if I can do this, the same. So this distance would have to be the same as that distance, and that looks roughly correct. So then if I do this, I do end up with a parabola. Every point, the distance to there and the distance to there would be the same. That looks roughly correct. It's not bad for me. That is the official definition of a parabola. And again, in the book, they go through the whole math thing. And of course, this is going to involve the distance formula, all that kind of beautiful stuff. I am not going to run through it. You can look at it if you want to. And you end up with one of the funkiest ways to represent this that you never would think existed. Oh, let me do this. Let me do the way that we know for sure already. All right, that is not a way that you're used to seeing a parabola, a parabolic, a quadratic, right? You're not used to seeing it like this. So P is very important because it tells me where the focus is and it tells me where the directrix is. Can somebody tell me the equation of this directrix? I love that. What's the equation of that directrix?
Y equals negative P.
Exactly. It's y equals negative P. So if P is negative, then this would be a downward parabola. This would be up here, the focus would be down there, and everything would be great. Yes? And we already kind of know that. It's just I'm not used to seeing shit over there. I'm used to seeing shit like over there, not shit over here, right? That's the difference. So here we go. Watch. If I do something like this, obviously figuring out what P is huge. What is P in this case?
8.
No.
Oh, 2.
2. I love it. It's 4 times what equals this? Kick ass. So P will be 2. Now I know where the focus is. And I know that it's on the y-axis because it's y equals x squared. So I know it's all about the y-axis. It's going to open up or down. If this was y squared equals 4px, it would open left or right. I just did like a Rudy Giuliani. I don't know if anybody. It was from the bottom to the top, from the side to the middle. All right, sorry. If you don't get that reference, I actually am a little jealous that ignorance is bliss. I gotta tell you. So the focus would be at 0, 2, and the directrix would be at y equals negative 2. So it basically looks exactly like this, where that's 2 up and 2 down. Here's another really nifty happenstance. I love that. This distance is called the focal diameter, which is kind of a neat thing because the diameter of a circle goes through the center. All right, that looks like, don't kick the baby. Yeah. The focal diameter of a parabola goes through its focus in a very similar kind of way. The focal diameter's length is the absolute value of 4p, because that could be negative. That's why it's the absolute value. So watch this. All right. So I know the focus, I really shouldn't make that a point. It's not a point in the graph, Jeff. The focus here is at 2, 0, 2. The directrix is at negative 2. I know it goes through 0, 0 because it's not shifted anywhere. I know the focal diameter is 8, meaning it goes 4 up. Now watch what that means. 4 up this way and 4 down this way. I can find points coming straight off of this. Oh, Jeff, straight off would be great. You could do it. Do you understand what I'm saying? The diameter is 4p, meaning this distance is 2p. Shoop. Shoop. Oh, Jesus. Make that big. Okay. All right. That's not horrible. All right. Let me see. Is there a quick way I can show you that? Yeah. So watch this. if I made P, I don't want to say this. What would X have to be if Y was P? Wouldn't X have to be 2P? I don't know if you guys understand what I'm saying. To get a value, an output of P, to be across from the focus. So I'm going to make Y P. X would have to be 2P or negative 2P, right? That's where the negative 2P and the positive 2P come in. I just did the same thing again. Left, right, down, up. All right. That is way more technical than you thought you could get with parabolas. But the importance of this is this kind of leads into stuff like satellite dish construction. So you can, if you want your focus to be in a certain place, you can construct your parabola so that it is right where it's supposed to be. So if you have a dish and you want your little dish collector thing to be in the right place, you better construct the sides the right way so the focus is where it's supposed to be. Or if you have a parabolic lens in a telescope, you probably want the focus in the right place. All right, maybe. So there's a lot more to this. That's why we have another more technical way to look at parabolas. Okay, I have no idea how you guys feel about that. But to be honest, even though this has got some technical pieces to it, it still is something you can sink your teeth into, I think, a little bit easier than some of the other stuff we've done this semester. So this shouldn't be too evil. All right. What time we got? Oh, cool. All right. Let's see. All right, let me see. Let me let you guys try one of these yourself. So what about yeah, let me see if you guys can handle this if I do y squared. We're all gonna find out together. Here we go. Yeah, I'll make it not too freaky, so yeah, not too bad. So hopefully I just gave it away that this is going to open left or right as I get some hiccups. Let me get rid of those. Please. Okay. I'll give you a little bit of help. So when you do this, also find these points too, right? While you guys do this, Bahaz, have you seen Re-Zero? If you're still out there, Bahaz. Oh man, okay, that's awesome. I thought maybe you would have heard that. How about oh shit, what was that one called? God, I can't remember now. Kibari. Oh, screw it. Re-Zero is amazing. Yeah, Re-Zero is the shit. Yeah. So obviously here P is 4, right? So I know then focus will be at 4, 0. The directrix will be at x equals -4. It does go through 0, 0 because neither one of these are shifted. And how far up and down do I go from here? Anybody? How far up and down will I go from the focus to find points?
Is it 8 from the?
Good. Yeah, because it'll be 16 all the way across. So it's 1, 2, 3, 4, 5, 6, 7, 8. There's 1 point. 1, 2, 3, 4, 5, 6, 7, 8. There's another point. And my scale is perfect. It goes from there. So this is always going to be, this whole length will equal that coefficient. It equals to absolute value because it could be negative, right? So that means this is half, this is 2p, and this is 2p. So if you ever see anybody talk about satellite dish or something and talk about focal diameter, now you know what that is. Okay, all right. So I gave kind of minimal homework on this because you don't have to do a lot of these to get the idea of it, I decided. So I just want to, unless there's any other specific questions on this, I want to do a little baby step into chapter 13, and then we'll finish that up tomorrow. Oh yeah, I forgot about the, dadgummit. Real quick, I forgot about this. This is really dumb. So if you have an ellipse, we did talk about this. It looks like this, and it's got a plus, and its focus equation has a minus. And again, the bigger one first, right? A and B don't matter, we're shit, just bigger one first. The neat thing about a hyperbola, and this should make some sense, its foci needs to be outside, like not really outside of it, but the foci here had to be less than that. For a hyperbola, you can do it, Jeff. The foci will be out here, so it's going to be more. So this equation is actually going to look like the Pythagorean theorem. Okay. So I almost forgot about that. So it's how to find the foci for an hyperbola. All right. And I remember this because the hyperbola has a minus in the equation already. So this better have a plus. This one has a plus in the equation, so this better have a minus. And that's one way to try to remember that. All right. Ooh, Joel. So, little baby step. The two main things in chapter 13 that I wanted to focus on. 13.1 is about sequences. And 13.4, I think it is about series. And the two in the middle, is that 2? 2, 3. Yes, you can do it, Jeff. 13.2 and 13.3 are about specific sequences that lead into this anyway. So we'll talk a little bit about these probably tomorrow, but tonight I want to talk a little bit about this. So, I mean, here's a basic sequence. Let's start off with really, really, really way too easy and just a real insult to your intelligence. But what is that? What's the next two terms of that sequence?
13, 16.
That's crazy. Is that the only possible answer? I mean, that's immediately obvious, right? That it looks like I'm just adding 3 every time, right? Let me think. Can I come up with something on the fly? I don't know, Jeff. Let's try it. Oh, shit. I probably can't. You can do it, buddy. Just try something, dude. Sure, maybe. Let's see. I don't know. What do you guys think about that?
Multiply them times 4.
Well, 4. Yeah, not really. Right.
No? Oh, never mind.
Multiplied by 3 plus 2. Are you allowed to do
Ooh,
that?
that's so cool. All right, you ready? That's so funny you said that. That's not what I was thinking, but that is exactly what I was just thinking because all right. Let me just show you what it is. All right. So that is not what I was thinking. So you said times 3 plus 2 times 3 plus 2. You guys see how that works? 26 times 3 is something. 78. Oh, so man, of course it's the same thing, Jeff. You crazy fool. Why does that work? Because, Jeff. So here's the way I created this. And of course it's mathematically the same, Jeff. I did 3 to the first minus 1, 3 squared minus 1, 3 cubed minus 1. Which is really, how do I want to say this? Which is really the same thing that you just did. So if I multiply by 3 and then add 2, that's the same thing as 1 less than, I don't know if you guys can see this. If I multiply by 3 and add 3, isn't that just always going to give me 3 to that? I don't know if you guys are with me at all. Anyway, mathematically, you do end up with the same exact numbers if you use my way or if you use that way. But there could be, I gave you so few numbers here. I'll bet you there's something else we could come up with. Do we really feel like doing that? I don't know. What else would it be, Jeff? This is plus, now here's what's funny is this would come up with the same idea. Plus 6, plus 18. So it looks like I keep adding 3 times. That would come up with the same number again because it's all based on 3. All right, enough. So the general idea I'm trying to get at is that with some sequences, if I don't give you enough, there are multiple patterns that will work. So you could have multiple answers. So if I give you a problem like this, and you come up with an answer that, and you got to show me your work, and then you get different numbers than I did, but your work works, you just discovered a different sequence that matches these things. I don't know if you guys know, this is called inductive reasoning. And I remember it's inductive and not deductive because inductive is like inflate. So if I take specific examples and say, oh, I know the general pattern now, that's a little overconfident. Maybe you can make a mistake. And that's, of course, the most basic mistake humans make. We make a generalization from a few examples. Good old inductive reasoning. All right, but, and of course, what about this guy? The most famous Rudolph the Red-Nosed Sequence. No. The most famous sequence of all. Does anyone know this one? Maybe not famous for everybody. Famous in math circles.
Are you adding the first 2 numbers together?
Yes. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. Has anybody ever gotten note cards to help you study? Anybody ever gotten note cards? What size do note cards come in? 3 by 5? 5 by 8? Right. No, maybe. Yeah. Yes. So this is called the Fibonacci sequence. And this guy's got an interesting story, but Fibonacci had a thought experiment about throwing rabbits in a room and letting them reproduce. And this represents that. It also represents if you look at a tree that hasn't been cut and you count the number of branches as it moves up. If you count across the number of branches, it will follow this very often. This is found in art. This is found in music. This is found in nature. This is found in finance. This is found in holy shit. So if you Google Fibonacci, put any damn words you want. Music, art, finance. You will get, a friend of mine who makes a lot more money than I do, used a Fibonacci approach to buying and selling stocks. And he made money during the recession using that approach. I'm like, that's nice for you, Sean. I don't have any stocks. Sorry. He's the guy that makes 6 figures but has 5 kids. So it's gone. All right, anyway. So here's the last thing I want to talk about tonight is just to lay the groundwork of notation for sequences. So this should look a little familiar if you remember the matrix stuff we did. So I can have a sequence and I can call it AN. And it would have elements A1, A2, A3, A4, blah, blah, blah. Okay. So I can have a sequence like defined as a function. And then I can figure out what the elements of that sequence are. Right, so the first one, n is 1, second one, n is 2. Isn't that insane? Third one, n is 3. And I can ask weird ass questions like, if I were to write this sequence out forever, does it seem to be approaching something? Are the sequence elements getting bigger or smaller?
Smaller, so they're approaching 0.
Yes. And in fact, if you look at this as a function, what would the horizontal asymptote be? The bottom power is bigger, 0, right? Holy shit, math is all connected. What? Sorry. All right, so next time we will finish up chapter 13 somehow. This is basically the sequence stuff here. There's not much more beyond this for the basic sequence stuff, to be honest. So we only have one section really. I'll discuss 13.2, 13.3 very quickly. We'll do 13.4, which is really what we need to definitely get through. And then that'll be it for the whole semester. So I got the practice final up on the page, up on Canvas. You guys can take a look at that. I'll probably put the solutions video up over the weekend. Yep, so that's it. That's enough for tonight. So let me know if you need to hang out. Otherwise, you are free to go.
For turning in like homework assignments like that are corrected and stuff, we're just supposed to put them back on the same
Yes.
thing. Okay.
It makes it easier for me because then I can go back and see your first submission, kind of go back and forth and see what went wrong and what went right, hopefully.
Okay, cool. Thank you.
Sure.
Bye, thank you.
See you guys. Is everybody else good? All right. I'm gonna head out. Goodbye.